So, Common Core, and I know you guys don't care about Common Core, but Mr. Daly does. So it really is in the Common Core. Functions, T for trig functions, 2, and it's the unit circle in the coordinate plane. Is an extension of trig functions, okay? With radians, and there it is, with radians. And that's what we're going to do. We're going to look at the unit circle in terms of radians. Pi thirds is radians, all right? So let's do this. Find all 6 trig ratios for pi thirds. So first of all, we're going to find the sine of pi thirds. We'll find the cosine of pi thirds. We'll find the tangent of pi thirds. We're going to find the cosecant of pi thirds. We're going to find the secant of pi thirds. And we're going to find the cotangent of pi thirds. All right? And it's actually going to be really easy. My circle is over here. So as I record, I'll refer to the circle. So sine of pi thirds. Okay, sine is the y value, right? Everybody agree? Yeah, you go to pi thirds, there it is. The y value is square root of 3 over 2. It's that easy. Okay, pi thirds, y value square root of 3 over 2. Square root of 3 over 2. Cotangent, pi thirds. Okay, there's my pi thirds, cosine, I said it wrong. Cosine is the x value, which is 1/2. Your calculator will give you the exact same answer, all right? Tangent, pi thirds. Well, tangent is going to be the y over the x. We already did that. It's just going to be the square root of 3, isn't it? And it's on our circle. It's just the square root of 3. Okay. Cosecant then is going to be 1 over the sine value, or 1 over the y, okay? So if I do 1 over, if I go to pi thirds, 1 over this, what am I going to get? Well, I might have to do a little side work. So what is, a little side work, I have 1 over the square root of 3 over 2, right? So do a little side work over here, scoot it over. What is 1 over the square root of 3 over 2? Well, 1 over any fraction flips it up, okay? All right? 1 over any fraction just flips it up to 2 over the square root of 3, okay? Just flipped it, right? 1 over any fraction just flips the fraction. But that's a pretty ugly answer, isn't it? So instead of 2 over the square root of 3, we can rationalize the denominator. So I multiply both top and bottom by the square root of 3 over square root of 3. Remember doing that? Rationalize the denominator. So we wind up with 2 square roots of 3 over 3. And that's the answer I want for cosecant of pi thirds is 2 square roots of 3 over 3. Okay? Secant of pi thirds. Well, secant is 1 over the x value. So I go to my unit circle, and it's 1 over the x, so it's 1 over 1/2, right? It's 1 over 1/2. Well, 1 over 1/2 should be easy to do. 1 over 1/2 is... It's 2. 2 over 1 or 2, right? 1 over 1/2 is just 2. And then finally, cotangent of pi thirds. So cotangent is going to be the x over the y. So cotangent is the x over the y, which is our 1/2 over our square root of 3 over 2. And we did a little bit of that, right? That becomes square root of 3 over 3, all right? We did that earlier. So this answer is just square root of 3 over 3. Now, the good news. The good news is that most of the time all we use is sine, cosine, and tangent, okay? That's good news. And the reason it's a good news is because all of those values are on the circle, right? This other stuff with secant and cosecant, cotangent, we don't do very often. Now, of course, I'll put a few of them on your quiz, but for the most part, we don't use these. And that's why we don't want to We don't want to gunk up the circle with all these others. It's going to get busy enough, right? So we'll leave these out, and we may have to figure these out the hard way, okay? Now, all 6 trig ratios for pi halves, all right? Let's do that. So sine pi halves, cosine pi halves. We're going to have a tangent pi halves. We'll have a cosecant pi halves. We'll have a secant pi halves. And we'll have a cotangent pi halves, okay? So we're going to do all 6 functions. Sine pi halves, cosine, tangent, cosecant, secant, cotangent, okay? Scoot this up a little bit, right? All right. Sine, cosine, tangent, cosecant, secant, and cotangent of pi halves. Sine is the y value, which is 1, right? So that's just 1. Cotangent's the x value, so it's 0. Tangent is the y over the x. I'm going to divide by 0. It's going to kick my asymptote, so it's undefined. We'll put empty set, but it technically is undefined, okay? I just use this symbol because it fits on the unit circle, okay? Cosecant of pi halves. Well, cosecant is 1 over the y value, right? So 1 over 1 is 1. Secant of pi halves is 1 over the x value. 1 over 0 is bad. Very bad. Undefined, right? Cotangent of pi halves. Cotangent is going to be the x over the y, which is just 0 over 1, which is 0. Okay. Now, let's look at some different angles. Here comes the easy stuff, okay? Cosine, 2 pi thirds. We're looking for the x value, right? X value, right? Let's go to 2 pi thirds. 2 pi thirds is here. We're looking for the x value. Negative 1/2, right? Is this easy? Good. Tangent, negative pi thirds. So tangent, negative pi thirds. So first of all, if pi thirds is here, right? Then negative pi thirds is here, okay? Now we have it on our unit circle. What is it?
Negative square root of 3.
You guys see it? Do you guys see negative square root of 3? Down there at 300 degrees? Negative square root of 3. Sine a 19 pi fourths. All right, it's not on the circle because we have to go around the circle a couple of times. So, really, 19 fourths. 4 goes into 19 how many times? 4 times. How many left over? 3/4 pi. Okay, you with me? 4 goes into 19. 4 times with 3 left over, so 4 and 3/4. So let's go around the circle, right? Let's take a journey, right? So if we go around the circle, ready? 1 pi, 2, 3, 4, and then I need to do 3/4, right? Which puts me right in there. And I'm looking for, what am I looking for again?
Sine.
Sine. That's it right there. Square root of 2 over 2, okay? So for my viewers, we go 1, 2, 3, 4, and 3/4 is here. Look at sine value, which is square root of 2 over 2, okay? Easy? Okay, now, secant of 2 pi thirds. Well, secant is going to be the 1 over the x value. So we can maybe do a little work. Oh, I hate these. Oh, we can do it. No, it's okay. So 2 pi thirds, there it is, right? And secant's 1 over the x value. Oh, this one's not that hard. Just going to have a 1 over a negative 1/2. What do you think that answer is? I agree with Madeline. Flip it up, right? Flip it up. Just negative 2. Good. Cosecant of 5 pi fourths. So cosecant's 1 over the y value. Okay, so go to 5 pi fourths. I'm going to use a circle. 5 pi fourths is right here. Okay. I'm going to have 1 over my negative square root of 2 over 2. Okay, so it's going to be 1 over negative square root of 2 over 2. Okay, we're going to do a little bit of work. little side work. You guys ready for a little side work? A little side work over here. What is 1 over negative square root of 2 over 2, okay? So I flip it first, okay? Flip it first. Make it 2 over negative square root of 2. Okay, you're right with that. Flip it first because 1 over a fraction just flips it. Now I can't have a square at the bottom, right? So I rationalize it. Square root of 2, square root of 2, right? Which will give me a 2 square root of 2 over negative 2, which is just negative square root of 2. Which just becomes a negative square root of 2 because the 2's cancel, right? So cosecant of 5 pi fourths is just going to be a negative square root of 2, okay? Cotangent of negative pi 6. So cotangent's got to be the x over the y. Pi 6 is this rotation, right? Negative pi 6 is down here at 330 degrees. So this is where I want to be. Instead of going up pi 6, I go down pi 6. So this is where I want to be, and cotangent's got to be the x over the y. It's going to be my square root of 3 over 2 over my negative 1/2. The 2's can cancel, and you're left with just plain old negative square root of 3. Thumbs up? Yeah, I'm sorry. Thumbs up? I don't see any thumbs yet. I see one. One thumb up. 2, 3, 4. Yeah. The only ones that are kind of hard are the cofunctions, right? All the rest are easy. Cofunctions take a little bit of work, but all the rest are easy, okay? Okay, turn the page. Okay, all right. Now, number 4. Wyatt, where are you? Wyatt, you asked a really good question, okay? So take a look at example 1. It says use a calculator. What mode do we need to be in? Mode. What do you think? What mode are we going to be in?
Degree?
I don't know. Do you see a little degree symbol?
Radian.
Radians. Now sine of 2. Where is 2 on my unit circle? 2 on my unit circle is right about here somewhere. Because I know if that's 3.14 and that's a 1.57, right? Then 2 is right about here, okay? This sine value. So you need the sine value of it. So the first thing I'm going to do is take my calculator and I'm going to change it to on mode. Go to radians, right? Go to radians. So change it to radians. Enter. Okay. And then I'm just going to go sine of 2. And I get about 0.91, okay? 0.91. 0.91. What does that mean? I want you to know, because so often we just get an answer, okay, 0.91, whatever, I got the answer right. What does it mean? Well, I want to show you what it means. So let me make myself a little mini circle over here, okay? A little mini unit circle. Okay, and let's see if I have a circle template. I really want you to get the gist of what we're doing, not just to be able to say, okay, I got an answer, what does it mean? Here's what I'm looking for. Let me put a circle on here. All right. Okay. Here's my circle. The sine is the y value, right? What's the radius of this circle? What's this point right here? It's 1, right? So if I have an angle of about 2 right here, what's the height? 0.91. Wow. Kind of makes sense. If you got an angle of 2, its height is about 0.91, because it's the y value, isn't it? Okay, secant of 1.2. Got a problem here. There's no secant button on my calculator. Gonna have a problem. Now, of course, some of you have a super fancy calculator. Elijah, you might have a secant button on your calculator, but most of us don't. But that's okay, because I know secant's the same thing as 1 over cosine. So that's all I'm going to do. I'm just going to go 1 over cosine of 1.2. I don't need a fancy button. I can just go 1 divided by cosine of 1.2, and I get an answer of about 2.76 approximately. Okay. Okay. Now, example 5. Let's jump off the unit circle. Now, how do I know I'm off the unit circle? Example 5. No, I'm not on the unit circle. How do I know that?
The quadrant.
that, and if cosine is the opposite over the hypotenuse, this is not 1 anymore, is it? Right? So I'm not on the inner circle anymore. So if it's quadrant 4, here's how I do these. First of all, let's just draw a quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You with me? We're going to do a lot of this. You get used to this, okay? We're going to do a lot of this. So whenever I see this quadrant thing, draw your quadrants, okay? Now, I'm going to have a triangle in quadrant 4, right? So, Zane, this is something you and I were talking about. When I draw my triangle, I have to draw it flush to the x-axis. Has to be. And here's why. 2 reasons. The most important reason is how we graph points. Over, down. Does that make sense? So if we graph over, down, we get a right triangle right in here, okay? You guys agree with that? Now, t is the angle, so I'll put t here. I like theta better, so I'll change it to theta, okay? They use t, I like theta, okay? And I kept it t on the worksheet because I wanted to show that. So when you see the notes in the homework, remember t, theta, same thing, okay? Just theta is easier, okay? So what do we know about cosine? Well, it's the adjacent of the hypotenuse, right? You guys agree with that? What's the opposite side? 4. How do you know it's 4? 3, 4, 5, try. We could do Pythagoras theorem. I could go 3 squared plus b squared equals c squared, right? And when you solve it, you get b squared is equal to 16. Then you get b is equal to plus or minus 4. You really do get plus or minus 4. You get plus or minus 4. Which one is it? Plus 4 or minus 4? Yeah, it's got to be minus 4. How come, Elijah? It's pretty obvious. How come? It's going down. Do you guys agree with them? It's got to be negative 4, okay? So, all right, let's do our trig functions. So, sine of theta. Well, sine is opposite over hypotenuse.
Do you just write SM for sine? Is that, oh, no, sorry, just looks like it.
No, that's okay, yeah. Cosine of theta, we already know, right? 3/5. I was in the actual directions, right? Tangent of theta is the opposite over the adjacent, right? You guys agree with that? Opposite or adjacent. So tangent is just going to be negative 4 over 5. The next 3 are easy. Cosecant of theta.
Is it negative 4 over 5 or negative 4 over 3?
It's negative 4 over 3. I made a mistake. There, I admitted on camera, huh? Cosecant is just the opposite of this. It's just the opposite. So it's just going to be 5 over negative 4. Secant is just the opposite of this. 5 over 3. Cotangent is just the opposite of this. 3 over negative 4. Easy squeezy, lemon peasy, okay? Here's the homework. 417, 6 to 22 even, 37, 38, and 64, okay?